Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is coordinate geometry. This is the second video on this particular topic. In the first video on coordinate geometry, we discussed about the section formula. We discussed about the distance formula, that is the distance between 2 points whose coordinates are given, and a few examples were also given in that video. In this particular video, we focus on the extra punch problems or the hot questions on coordinate geometry. This will be very useful for your examination. So be ready with pen and paper. In the first problem, we want to find a point on the y-axis which is equidistant from -5 2 and 9 minus 2. Equidistance means same distance from this point as well as from this point. Find a point on the y-axis. On the y-axis we know that x coordinate is 0. So the point will be 0 y. Already 0 is given, it is on the y-axis, and y we need to determine. Since this point 0 y is equidistant from -5 2 and 9 minus 2, we use the distance formula to find the distances between these two, and these two distances are equal. So let us find from -5 to 0 y what is the distance. So -5 minus 0, 2 minus y, the whole square under square root. This is equal to 9 minus 0 the whole square minus 2 minus y the whole square. Now taking square on both sides, the square root term will go and the balance will be minus y square 25, and we will square this. 4 plus y square minus 4y, and on the right hand side will be 81 plus 4 plus y square plus 4y. Y square term will go, 4 term will go. We will take minus 4y on the right side, so it will become 8y, and 25 minus 81, it will be minus 56, and once we divide minus 56 by 8, we will get y as minus 7. So the point is 0 minus 7, which is equidistant from -5 2 and 9 minus 2. This is the answer. In the second problem, we are given 3 points A, B, C whose coordinates are given. They are the vertices of a triangle ABC. So ABC is a triangle whose coordinates are given. Then find the length of the median through the vertex A. So what is a median? A median divides a side into two equal parts. So if AM is the median through the vertex A, then M point is midpoint of BC, that is BM is equal to MC. This is the definition of the median. So how do you get the midpoint? Midpoint is nothing but adding each coordinate and dividing it by 2. So what is the coordinate for point M? M will be xy, where x will be 0 plus 4 divided by 2. The x coordinate will be x coordinate of B plus x coordinate of C divided by 2. Similarly, for M coordinate, the y coordinate will be y coordinate of B plus y coordinate of C, 0 plus 2 divided by 2. So this is the midpoint formula we already discussed in the first video. On solving, we will get 4 divided by 2, which is 2, and 2 divided by 2, which is 1. So what is the coordinate of M? M is 2, 1. We have to find the length of this median. So that is why we needed the coordinate of M. So once we get the two coordinates, we can find the length AM using the distance formula. So we use the distance formula to get AM as square root of 2 minus of minus 2 the whole square plus 1 minus 4 the whole square. This is the distance formula between 2 points x1 y1 and x2 y2 is square root of x2 minus x1 the whole square plus y2 minus 1 the whole square. So let us put how much this will be. 2 plus 2 4 square 16 minus 3 the whole square 9, 16 plus 9 25, square root of 25 is 5. So AM is 5. This is the final answer. This is the length of the median AM. This is the answer. Let us take another problem. In this, a circle whose center is given at A12. So this is the center of the circle, and it passes through a point B35. So it passes through a point B35. Circle is passing through a point 35 whose center is given. We need to find the diameter of the circle. Now since center is given and a point on circle is given, AB will be the radius of the circle. Correct? So once AB is known, we can multiply it by 2 to get the diameter. So we find first the radius. R is AB. Again we use the distance formula when coordinates of 2 points are given, A12 and B35. We get the distance as 3 minus 1 the whole square plus 5 minus 2 the whole square and taken the square root. So 2 square will be 4, 3 square will be 9. The radius is square root of 13. Since we are asked to find the diameter of this circle, we need to multiply the radius by 2. So D is equal to 2R equal to 2 root 13. This is the answer. The next problem, we see that the length of a line segment is 13 units. Let the line segment AB has a length 13 units and the coordinates of one end point are minus 6, 7 and another is minus 1 and y. It is given like this. If the abscissa of the other, abscissa means the x coordinate and ordinate means the y coordinate. So if the abscissa of the other end is minus 1, so minus 1 is the x coordinate. Find the ordinate of the other point. We need to determine y. It is also actually a straightforward problem. In this, generally 2 points whose coordinates will be given and we have to find the distance. In this particular problem, distance is given and one of the ordinate we need to find, or one of the coordinates are to be determined. So again we use the distance formula. We know that AB distance is 13 and we use the distance formula, this formula. So minus 1 minus minus 6 the whole square plus y minus 7 the whole square root will be 13. To remove the square root, we have seen we have to square on both sides. So this term will be 169 and inside this will be a 5 square 25 plus y square plus 49 minus 14y. On simplification of this, we will get a quadratic equation y square minus 14y minus 95 equal to 0. On simplification of this. Now we know that there are two ways to solve the quadratic equation. One is the factorization method where we split the middle term. In the easier method, we directly apply this formula where a is the coefficient of here y square, b is the coefficient of y and c is the constant term. So a will be 1, b is minus 14, c is minus 95. On putting in this formula y, we get it as minus 5 and 19. Generally for a quadratic equation, we get two values as the solution. Here we get minus 5 and 19. So both are possible values. So the point B is minus 1 and minus 5. Minus 1 is already given. And the second point could be minus 1 or plus 19. So there are 2 points for point B. In this particular problem, we are given 3 points or 3 coordinates of points A, B, C. We have to find which point is nearest to the origin. This is very important, friends. Please note that the coordinate of origin is 0, 0. So we need to find distance OA OB and OC, and then find which is the smallest value. So that point will be nearest to origin. So let us find OA. So 1 minus 0 plus 3 minus 0 the whole square, we get 9 plus 1 square root 10. Similarly, OB will get minus 3 minus 0, 2 minus 0. We are finding distance from 0, 0. So everywhere the second coordinate is 0, 0. We will get square root 13. Similarly, OC will be square root of 3 minus 0 square plus 4 minus 0 is equal to square root 25. We are not simplifying square root 25 because we want to compare. Since root 10 we cannot get a full integer answer, we keep root 25 as it is. So on comparison we see that the smallest value is root 10. So the point A is nearest to the origin. This particular problem uses the section formula where we have to find the ratio in which the line segment AB, whose coordinates are given, is divided by the x-axis. Also find the coordinate of the point of division. So we need to find a point Px0. Why we have put 0 here? Because it is divided by the x-axis. In the x-axis y is 0. So that is why we are trying to find out the point P x comma 0 which divides this line AB in the ratio k is to 1. We also need to find the value of k. So we know the section formula that if x1 x2 y1 if x1 y1 and x2 y2 are divided by a point P in the ratio k is to 1, then there the coordinates of P will be kx2 plus x1 plus k plus 1 ky2 plus y1 divided by k plus 1. So this is the section formula. Just we substitute here. So k into x2. x2 is minus 4 plus x1 is 1 divided by k plus 1 divided by k plus 1. Similarly, we put the other one, k into 5 minus 5 divided by k plus 1. Now we observe that this is the coordinates of this particular point P. We have to find k first, but how do we find? We see that this particular ordinate value, since it is divided by the x-axis where y is 0, this particular quantity will be 0. That is, we compare with this, we see that this term will be 0. So we substitute k5 minus 5 by k plus 1 0, cross multiplying this will k plus 1 into 0 will be 0. So 5k will minus 5 will be 0, so k will be 1. So the required ratio is 1 is to 1. The point P is dividing these points A and B in the ratio 1 is to 1. Now we also need to find the coordinates of the point of division. We need to find x also. So we will substitute back in this. So k will be 1 into minus 4 plus 1 by 1 plus 1. And this term already we know it is 0. So on substitution we will minus 4 plus 1 minus 3 divided by 2. So the coordinates of point P will be minus 3 by 2 and 0. In this problem, the point P which divides the line segment joining the points A and B in the ratio 2 is to 3 lies in which quadrant? So we need to find where does this point P lies. To know that, we need to find whether x is positive, negative, or y is positive or negative, or we need to find the point P. First we need to find the coordinates of this point P, and then we know in a graph we know this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. We will plot this P and see where does it lie. So again we use the section formula here. This is divided into ratio k is 2 is to 3, or m1 is 2, m2 is 3, x1, y1 is 2 and minus y, x2, y2 is 5 and 2. We just substitute here in the section formula and get the coordinates of P. So we are trying to find the coordinates of P. So m1 is 2, 2 into 5, x2 plus 3 into x1, which is 2 divided by 2 plus 3. Similarly, we substitute in m1 y2 plus m2 y1. This is x1 y1, this is x2 y2. So on simplification, we get the coordinate as 16 divided by 5 and minus 11 by 5. Let us plot this. When x is positive and y is negative, we know that in fourth quadrant, x is positive and y is negative. So this point is lying in the fourth quadrant. This is the solution. Please note that on the first quadrant, x will be positive and y will be positive. In the second quadrant, x is negative, y is positive. In the third quadrant, x is negative, y is negative. In the fourth quadrant, x is positive and y is negative. So that is why we are getting this particular point in the fourth quadrant, because x is positive and y is negative. In this problem, we are given vertices of a parallelogram ABCD. A as this coordinate, B, C and D. The coordinates are given and somewhere we need to find A and B. So we need to determine A and B such that they are the coordinates of a parallelogram ABCD. So we know that diagonals of a parallelogram bisect each other. So O will be midpoint of AC and O will also be a midpoint of BD. This is by definition. So we know that midpoint of AC is equal to midpoint of BD in a parallelogram. So how do you find AC midpoint? A and C midpoint we know. We have to add x1 plus x2 divided by 2. So minus 2 plus 4 divided by 2 and 1 plus B divided by 2. So this is the midpoint of AC. Similarly, midpoint of BD we will find from these two. So A plus 1 by 2 will be x coordinate and 0 plus 2 by 2 will be y coordinate. So these two are same. So on comparison, we will check 4 minus 2 is 2, 2 divided by 2 is 1. 1 will be equal to A plus 1 by 2, which is equal to 1. A will be 1. Similarly, we will compare this also. 1 plus B by 2 is equal to 2 by 2, which is 1. So on cross multiplying, we will get B as 1. So A and B value is 1. This is the final answer. Let us take another interesting problem. In this, we are required to find the area of a rhombus ABCD whose coordinates are given. So you know the definition of rhombus. It is a four-sided figure whose diagonals are bisected at 90 degrees. This is 90 degrees. This is the definition of rhombus. And what is the area of a rhombus? Area of rhombus is given by half into product of length of diagonals. So we need to find the diagonals BD and AC. We need to find their length, then we need to multiply them and divide by 2. So we will get the area of rhombus. Since the coordinates of A, B, C, D are given, here it is given, we can easily find the diagonal length through the distance formula. So let us find AC first. AC will be from this two coordinates, we will see that minus 1 minus 3 the whole square plus 4 minus 0 the whole square. So minus 1 minus for 16 plus 16 will be root 32. So length of this diagonal, first diagonal AC is square root 32. Similarly, we will find BD. We will find BD. So BD is minus 2 minus 4 the whole square minus 5 the whole square. So this will be minus 6 the whole square is 36. This will be minus 6 the whole square again 36. So this will be square root 72. Let us find the area. Area we know half into product of diagonal. So half into AC into BD. So what is AC? Root 32. Root 32 is root 16 into root 2. What is root 16 is 4. So we can write it as 4 root 2. Similarly, what is root 72? Root 72 can be written as root 36 into root 2. So root 36 is 6. So 6 root 2. So half into 4 root 2 into 6 root 2. What is root 2 into root 2? 2. So 2 will get cancelled with the denominator 2. So we are left with 4 into 6. So the area will be 24 square units. Friends, with this we conclude this chapter on coordinate geometry. I request you to please give a thumbs up to this video. This will motivate me to make more such good videos for you. Also, my sincere request to you to please subscribe the channel. Thank you very much, friends.